This is 1.3b. Day 1. So our essential question today, what we're trying to determine is, how can I tell if two lines are parallel, perpendicular, or neither? Parallel lines are two lines that never intersect. They have the same slope, and we use railroad tracks for our symbol. Simultaneous lines are two equations that represent the same line. We'll talk more about that further down in the notes. Perpendicular lines, two lines that intersect at a 90-degree angle. Their slopes are negative reciprocals. And we use the upside down T as a symbol for that. Recall that negative reciprocals, you change the sign. So from negative to positive or positive to negative, and flip the fraction. So some examples would be 6 and negative 1/6, undefined and 0 slope, and 6/5 and negative 5/6. Those would be some examples of negative reciprocals. So, parallel perpendicular slopes. This is level 2. And so what we need to think of is that I need to solve for y. So the first step will be to add or subtract the x term. And the second step will be to multiply or divide, and it's usually divide by the y coefficient. That's the number in front of the y. So for number 1, we're given an equation in standard form. It's not solved for y, so I need to do that. So the first step, I'm going to subtract the x term. So that 2y equals negative 2x minus 12. And then we're going to divide by the y coefficient. Y is negative x minus 6. So our question is, what's the slope of the line parallel? So the line that I'm given, A, is negative 1, and that comes from right here. So then slope parallel is also negative 1 because parallel is the same. So those are the steps that we're going to go through for this section. What is the slope of a line perpendicular to a line whose equation is y equals half x plus 4? So we're looking for perpendicular. It says solve for y, but I already have y. So then I can notice that my slope is half. So A is 1/2. So perpendicular slope, we're going to change the sign and flip the fraction, and then when we simplify it, it's -2. So these are perpendicular because they are negative reciprocals. Number 3 gives us a equation in standard form, so I have to solve for y again. And this time I'm looking for parallel. So first step, we're going to add or subtract the x term. So I have -6y, which is -5x plus 30. Then we divide by the y coefficient, that's just the 6, or in this case the -6. So we're left with y equals 5/6, because two negatives make a positive, minus 5. There's my slope. So the slope of my line is 5/6. So parallel slope is also 5/6 because parallel is the same. Okay, number 5 goes back and references our negative reciprocals. We've talked about this. So we talked about Hoy-Vux. And what that means in terms of vertical and horizontal lines. So this is a y line. That means that I'm dealing with a horizontal line with 0 slope. So when I graph this, this is y equals -4, and this has 0 slope. So when I do one perpendicular, that's a vertical line. Vertical lines have undefined slope. So this is x equals a constant, and our slope is undefined. So if I want slope that is perpendicular, a perpendicular is undefined. So those are level 2 questions. Level 3 questions we have to determine parallel, perpendicular, or neither. So not only do we need to know what the slope is, but I have to look at two separate lines and determine what the relationship is between those lines. So let's start with what's the slope for the formula. What is the formula for the slope of a line? So A, remember that's what we're using for slope, is delta y over delta x. And what we're going to do is we're going to find the slope for each line. And compare them. If they're the same, then that means the lines are parallel. If they are negative reciprocals, that means they're perpendicular. And if they're not parallel and not perpendicular, that means that they are neither. And we'll give some examples of those. So let's start with number 1. I'm given 2 lines, and the way that I'm given those lines is a set of coordinates. So we're going to look at the slope of line AB. So that's x1, y1, x2, y2 for points A and B. That's delta y over delta x. That's 6 minus 3 over 2 minus a -2. That's 3/4. So that's the slope for my first line. My second line, the slope of CD, x1, y1, x2, y2, is still delta y over delta x. This time, that's 3 minus 0 over 3 minus a negative 1. So that's 3 over 4. So when I compare my slopes, they have the same slope, therefore they are parallel. When we look at number 2, this time I'm given an equation and 2 points. It doesn't change anything, I still just have to compare them. So we start with the slope for PQ. That's points, so I label my points. And so delta y over delta x, that's 5 minus 6 over 4 minus 2. So that's negative 1 over 2. So that's the slope for my first line. The slope for my second line, the slope of RS, that comes from my equation right here. So that slope is 2. So when I compare these are negative reciprocals. Negative 1 over 2 and 2 over 1. The signs change and the fraction flipped. Therefore, these are perpendicular. Number 3 goes back to 2 sets of coordinates. So the slope of AB is 6 minus 8 over 2 minus a negative 1. So that's negative 2 over 3. So then when we do the slope of CD, x1, y1, x2, y2, I get 3 minus 2 over 3 minus a negative 1. That's 1 over 4. These slopes are not the same, not negative reciprocals, therefore they are neither. Number 4 gives us an equation in standard form and an equation in slope-intercept form. So the first one's easy. The first slope, A, is 3 over 2. The second one takes a little bit more work. So we're going to subtract 6x from both sides. So I get negative 4y equals negative 6x minus 8. Then we divide by the y coefficient. So that y equals 3 over 2x plus 2. So when we look at this slope, I have 3 over 2 and 3 over 2. So at first, looks parallel. But let's look at our equations carefully. Notice that this is 3x plus 2, and so is the new equation that I rearranged. These are the same equation. We call these simultaneous equations. Since they have the same slope, the same equation, remember parallel is two lines that never intersect. If it's the same line, they intersect at every point because they're laid on top of each other. So this is neither. So when you have simultaneous equations, they are neither parallel nor perpendicular. Now let's look at number 5. Number 5 again gives me two sets of coordinates. So I have the slope of AB, x1, y1, x2, y2. That's -10 minus a -8 over x2, y2. That's -2 minus 5. So that gives me -2 over -7, which is 2 over 7. So there's my first slope. So then we look at the second slope, the slope of line CD. This is x1, y1, x2, y2. When I subtract, that's 1 minus a -13. Over -2 minus a -6. So that's 14 over 6. That's not right. -2 minus a -6. I don't know where I got the 8 from. -6. Let's change that. So that's 14 over 4, which is 7 over 2. So now be careful of these two slopes because they are reciprocals, but they are not negative reciprocals. So these are neither. So because they have the same sign, they are not perpendicular. It has to be both. In our final example, we have two equations that are in standard form. So 2 times I have to rearrange my equations. So I have x plus 6y equals -36. Subtract the x term. 6y equals -x minus 36. Divide by the y coefficient. Y equals -1 over 6x minus 6. So there's my slope. The second equation, -12x plus 2y equals 18. We're going to add this time. That's the first time we've done that. We're going to add 12x to both sides. Remember, that's why it says plus or subtract. So then I have 2y equals 12x plus 18. Then we divide by the y coefficient so that I get y equals 6x plus 9. Here's the slope. So these are negative reciprocals, -1 over 6 and 6 over 1. Therefore, these are perpendicular. So when you look at the summary for this, remember we're trying to summarize or explain to ourselves in the future what we did today. I feel like the best way to do that is right here. For each of these problems, we found the slope, and then we had to find parallel or perpendicular. Even on the first page for level 2, we found the slope, and then we had to identify what parallel or perpendicular slope was going to be. For level 3, we had to compare them. So I found the slope for each line, and if they were the same, they were parallel. Negative reciprocals, be careful. And if it wasn't either one, then it was neither. Also, don't forget that simultaneous equations, the same equation, just written two different ways, is neither.